Hashing. Suppose we want to design a system for storing employee records keyed using phone numbers, and we want following queries to be performed efficiently. First, insert a phone number and corresponding information. Search a phone number and fetch the information. Delete a phone number and related information. For arrays and linked list, we need to search in a linear fashion, which can be costly in practice. So hashing is the solution that can be used in almost all such situations, which are extremely well compared to above data structures like array, linked list. Hash function. A hash function is any function that can be used to map a data set of an arbitrary size to a data set of fixed size, which falls into the hash table. The values returned by a hash function are called hash values, hash codes, hash sums, or simply hashes. To achieve a good hashing mechanism, it is important to have good hash function with the following basic requirements, such as efficiently computable, that is, it should be easy to compute and must not become an algorithm in itself. Also, second, uniform distribution, that is, it should provide a uniform distribution across the hash table and not result in clustering. Also, we need to keep a note of one thing, that is, irrespective of how good a hash function is, collisions are bound to occur. Therefore, to maintain the performance of a hash table, it is important to manage collisions through various collision resolution techniques. We will be discussing about collisions later in our video. Hash table, an array that stores pointers to record corresponding to a given phone number. An entry in hash table is nil if no existing phone number has hash function value equal to the index of the entity. You must be wondering what is O1 in this slide, and O1 is used to calculate or check the time complexity of hash. We are considering here a string s, which has a value equal to abc and we will be writing a program to calculate the frequency of occurrence of each alphabet in the string. So using this function O, we will be calculating the time complexity of this approach, where n is the size of the string, which in our case is 6, and 26 is the n is the size of the string, and there are possibly 26 characters, or obviously 26 alphabets in English. Here this is the program in which we have an for loop up to z, 26 alphabets, and in a loop there is also a for loop which is calculating the frequency or the count of each alphabet occurring in the string. The output which gives the number of times each alphabet occurred in our string. So here you can see A twice, B twice, C only one time, D only one time, and the other alphabets have occurred 0 number of times. Chaining. Since a hash function gets us a small number for a big key, there is possibility that two keys result in same value. The situation where a newly inserted key maps to an already occupied slot in hash table is called collision and must be handled using some collision handling techniques. And chaining is one of the collision resolution or handling techniques. So what is chaining? The idea is to using chaining Our idea is to make each cell of hash table point to a linked list of records that have same hash function value. Chaining is simple but requires additional memory outside the table. So how to handle collisions? There are mainly two methods to handle collision. First is separate chaining. The idea is to make each cell of hash table point to a linked list of records that have same hash value. Advantages: Simple, it is very simple to implement. Hash table never fills up. We can always add more elements to the chain. Less sensitive to the hash function or load factors. It is mostly used when it is unknown how many and how frequently keys may be inserted or deleted. Disadvantages of separate chaining, these are very important. Cache performance of chaining is not good as keys are stored using linked list. Open addressing provides better cache performance as everything is sorted in same table. Wastage of space. And third is, if chain becomes long, then search time can become uh, worst case. In worst case will be very big. And fourth, it uses extra space for links. Linear probing, also called open addressing or closed hashing. In linear probing, we linearly probe for next lot. In open addressing, instead of in linked list, all entry records are stored in array itself. When a new entry has to be inserted, the hash index of hashed value is computed and then array is examined starting with the hashed index. If the slot at the hash index is unoccupied, then the entry record is inserted in slot at the hashed index, else it proceeds in some probe sequence until it finds an unoccupied slot. The probe sequence is the sequence that is followed while traversing through entries. In different probe sequences, you can have different intervals between successive entry slots or probes. When searching for an entry, the array is scanned in the same sequence until either the target element is found or an unused slot is found. This indicates that there is no such there is no such key in the table. The name open addressing refers to the fact that location or address of item is not determined by its hash value. Also, linear probing is when interval between successive probes is fixed, usually to 1. And the advantages or the assumptions that we take during the implementation of hash table with linear probing are: there are no more than 20 elements in the dataset. Hash function will return an integer from 0 to 19, and dataset must be having unique elements. Double hashing is a collision resolving technique in open address hash table. Double hashing uses the idea of applying a second hash function to the key when collision occurs. uh, Hash uses different hash functions, and where and a good hash function is, first, it must never evaluate to 0, and second, must make sure that all cells can be probed. Double hashing is similar to linear probing but has many applications as compared to linear probing. First is associative arrays. Hash tables are commonly used to implement many types of in-memory tables. They are used to implement associative arrays, arrays whose indices are arbitrary strings or other complicated objects. Second, they are used in database indexing. Hash tables may also be used as disk-based data structures and database indices, such as in DBM. Third is caches. Hash tables can be used to implement caches, that is auxiliary data tables that are used to speed up the data to access them, and which is primarily stored in slower media. And the fourth application is object representation. This means several dynamic languages such as Perl, Python, JavaScript, and Ruby use hash tables to implement objects. So object representation. And the last application, and one of the most important application, is hash functions are used in various algorithms to make their computing faster. It really makes them work faster. Hash function.
So here we start with our topic indexing. So firstly, what is indexing? So the definition says that indexing is a common method for keeping track of data so that it can be accessed quickly. However, computer-based indices may be may point to a physical location on the disk or a logical location that points elsewhere to the actual location. So indexes are used by all types of softwares including operating system, database management system and applications. For example, each file system index in an operating system contains an entry for each file and the starting location of the file on the disk. So indexes are nothing but a way to assign data some particular values so which could be used to access the data in a proper way, in an easier manner. So let me tell you something more about indexing. Indexes are used by all types of software, like including the operating system, the very operating system which we use, which could be which could be uh, like Windows, Apple, iOS, etc. So database management it is also used by database management system and applications. For example, the file system index in an operating system contains an entry for each file, a name and starting location of file on the disk. All this you can understand is done just for the purpose so that uh, easily the data could be accessed in a proper way. In mathematics and computer programming, index notation is used to specify the elements of array of numbers. The formalism of how indices are used varies according to the subjects. Yeah, so here is an example. We see an array of 1, 2, 3, 4, 5, 6, 7, 7 integers. So if we talk about programming, their array is made of a single data type. Yes, here it is of all of integers, and the indices that are assigned are 0 for the first, 1 for the second, 2 for the third, and so on. So this is the way. Uh, in Java, the indices are assigned in such a family. So if we say that on the zero position of array, let's say a, 3 integer 3 is kept, it would be absolutely true, and on first position 8 is kept. So when we want to access the first element, we would actually write the index 0 in front of the array name if we want to first element, and we would write the index 1 in front of the array name if we want to access the second element. Okay, so this is a basic example for the same. Now we move further. So now we go on to the types of indexing. Indexing is defined based on the indexing attributes. Now attributes are nothing but just the properties. Indexing can be of the following types. So here we see the three types, which are primary index, secondary index and clustering index. Clustering index is the one which you might find new. So primary index is simple. Primary index is defined as the ordered data file, the file which contains ordered data. Ordered data is the most simple thing to understand, the data which is arranged in a systematic way in an ordered manner. The data file is ordered on a key field. The key field is generally the primary key of the relation. Yeah, key field might sound something new to you. So the key field is generally the primary key of the relation, the primary key of the relation. Now secondary index. Secondary index will be generated from the field which is a candidate key and has a unique value in every record, or a non-key with duplicate values. So it is not actually a key, it is a non-key which contains duplicate values. Now the clustering index. Clustering index is defined on an ordered data file. Here also primary index is also defined on an ordered data file, and clustering index is defined on an ordered data file as well. The data file is ordered on a non-key field. So you might wonder that some similarities you might find in secondary index and clustering index, like the data file is ordered on a non-key field, and this also or a non-key field with duplicate values. So let me show you a better explanation for this. A comparison table. So the comparison table, where is it? Yeah. So in the comparison table, there are types of three types of single level indexes: primary index, clustering index, and secondary index. So primary index is ordered file, secondary index is also ordered file, and clustering index is an ordered file as well, as we saw in the last slide or whatever. So data file is ordered on a key field, as we saw earlier. Data file is ordered on a non-key field in clustering index, and in secondary index as well. Data file is maybe ordered may have a candidate key has a unique value or a non-key with duplicate value. Now the last difference or comparison maybe the primary index is non-dense index or sparse index, and the clustering index is also non-dense. But in case of the secondary index, if key is present, then it is dense. If it's key secondary index, then it is dense, and if it's non-key, then it is dense or sparse index. So moving further on the next slide, or next topic, some more types of indexes are there which I want to discuss. As we saw in the last comparison, that there are the three types of indexes. So I was telling you there were three types of indexes, and we just learned the comparison between them. Now here came a word. It is a non-dense index, and if key, dense index. If non-key, dense or sparse index. So what is a dense index? In a dense index, there is an index record for every search key value in the database. So index record for every search key value in the database means that if you consider this particular example, so here uh, in China is assigned an index which points China, and after that inside that also it it points another you may call data which is Beijing, and inside that as well there is another form of data or another type of data which probably here shows the information regarding some population kind of stuff. So by this example, you may note that in a dense index, there is an index record for every such key value in the database. This makes searching faster but requires more space. As you can clearly see, more space is required as the number of data and number of levels are also more small. So this makes searching faster but requires more index. Index records contain such search key value and a pointer to the actual record on the disk. This you might call this as the pointer. So next comes the sparse index. So what is a sparse index, Manvendra? So in a sparse index, index records are not created for every search key. So index records are not created for every search key. So these are the search keys, and index record for like this search key is not created, as you can see in this example. An index record here contains a search key and an actual pointer on the data on the disk. So how can we search data in this? Here is the solution. To search a record, we first proceed by index record and recheck the actual location of the data. If the data we are looking for is not where we directly reach for the following index, then the system starts sequential search until the desired data is found. This may, the last line which I just told, this may reduce the speed up to a bit, but not much. So it's a sparse index, not much complicated or stuff. So the last time I tell you is multi-level index. So multi-level index is what there are three levels: outer index, inner index, and data blocks. So data blocks are the blocks which contain the data. Inner index is type of index, and outer index is another type of index which is primarily accessed by the user. So index record comprise search key values and data pointers. Multiple index stored on the disk along with the database. So the important thing is that if single level index is used, then a large size index cannot be kept in the memory, which leads to the multiple disk accesses. So multiple disk access, one may understand this. So this is all an index: multiple index, sparse index, and dense index.
So now finally, after we are done with all the indexing techniques and the basic introduction as well as the type of indexes, I'm going to illustrate an example of indexing in array while we'll be working on Java for the same. So for illustrating this in Java, I'll be using Notepad++. So here I make a new file and we start with the program. So let me make a class first of all. No, I should probably save this first. So Java source file, and it's done, I suppose. On desktop I want it. So
taking some time. It's taking some time. Mm. So here we are. So for defining an array, first of all, let me assign it a data type, integer a. Let's make it an array, and new integer, and the size of our array would be 20. So after doing this, we have already made an array successfully, and the size of it is 20, and the indexing, as I told you in the previous part, would start from 0, 1, 2 and so on to 19. So from here on, we can assign some values to all the positions in the array. Let me first assign from 0 is equal to 1. Let's make it 10. A of 1. Let's make it 20. I'm going to copy this. 4, 3, 2. So let's make this. So here we are done assigning all the values to the first probably 1, 2, 3, 4, 5 elements of the array. Now let me show you that the values are properly assigned by printing the elements on these particular positions. So system.out.println a of 0, control v, control v, control v, 3, 2, 1, and lastly control v a of 4. So let's save this document and go to our command prompt and javac prog.java. So it is compiled with no errors, as you can see, and now let's run the file in Java test. So here this command prompt window, let me show you so you can understand more easily. So this window here, the first we print the element at the position a of 0. So a of 0 has got 10 as we assigned it earlier here. A of 1 has got 15 as we assigned here. A of 2, 3, 4 are 20, 30, 40 respectively. So we are all done, I suppose, and clearly you can see that the indexing starts from 0 and ends at the number 19. So that's all for the day, and thank you so much.